Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ismail bin Amran from Matrix CF200162. So today I'm going to present about our structural design project, which is we have to design our own size beam. So first of all, what is structural design? Structural design is crucial in our daily life. Structural design will also impact how the building looks, how long it can endure the environment surrounding it, how long it can last before collapsing, and other factors. A beam. A beam is a structural element that resists load applied laterally to its axis. Beams are typically used to describe building or civil engineering structural elements. The sum of all the force acting on the beam produce shear force and bending moment with the beam, which cause internal stress, strain, and deflection. Furthermore, beams are distinguished by their support method, profile, cross-sectional shape, equilibrium, condition, length, and material. After a long discussion, we decided to make our double-story house, which is located at Jalan Anggerik, Sungai Buloh, Selangor, Darul Ihsan. We decided to use concrete grade 25 C25 and concrete strength of FCK is 25 Newton per millimeter square. Our FIK is 500 Newton millimeter square. Beside that, we chose R16 as our house fire resistant standard. It is because of to ensure that our double story building can last longer and delay the spread of fire throughout the building in the event of a fire. We just calculated our GK and QK and we decided to use GK for 4.69 and QK 1.63. Next is objective. What is our objective? To gain an understanding of the general basic structural design principle that civil engineers must understand as a future engineer, so we must learn and know how to do it. Second is demonstrate fundamental understanding of structural stability requirement through structural layout, planning, and arrangement. To analyze the structures in order to estimate and analyze the action acting on the slab and beams in accordance with BS 18110 and MSEN 1991. Next is objective. What is our objective? Our objective is to gain an understanding of the general basic structural design principle that civil engineering must understand. So as a future engineering, so we should learn and know how to do it. Next is demonstrate fundamental understanding of structural stability requirement through structural layout, planning, and arrangement. Next is to analyze the structure in order to estimate and analyze the action acting on the slab and beams in accordance with the British Standard 8110 and EN 1991. Next is analyze the reinforcement concrete beam and design it in accordance with British Standard 1992 using appropriate load combination. And lastly, to produce beam design detailing that complies with code and engineering best practice. That's all from me. Thank you. Assalamualaikum.
Assalamualaikum and hi. My name is Hamim Daniel bin Hartika. My matric number is CF200105 and I'm from group 3. Today, I want to explain my part, which is simply supported beam A1 to 5. Okay, for the calculation of beam A1 to 5, I want to make it simple and fast. For our beam A1 to 5, the width is 7 to 6 mm. Meanwhile, the length is 5 to 50 mm. Another that the characteristic action was all same, which is the permanent GK is 4.96 kilonewton per meter cube and the QK is 1.63 kilonewton per meter cube. The fire resistance we use are R60 and the exposure class was X63. So the characteristic strength of concrete FCK and FYK was same, which is 25 and 500 for the both. For the we assume the bar 1 is 16 mm and bar 2 is 12 mm and the link is 8 mm. Okay, for my part, which is my beam, I calculate that my beam was 600 mm and the B is 300 mm. So it is equal to 300 times 600 for my beam. Okay, next to the next page, which are durability, fire and bond requirements, which are all of our group members was used the same method. We get the C depth was 10 mm and the C norm is 34 mm. Then we next to the next part, which is loading. For the loading, the surf weight of our beam, for my beam, was 2.75 kilonewton per meter cube, and the finishes and ETC was 0.44 kilonewton per meter cube. GK and QK was 4.69 and 1.63, same with the before. Okay, as you can see, these are all calculation that I made. Next to the next part, and for the analysis that I can make, for the V, I get 132.68 kilonewton for the SFD. Meanwhile, the BMD, I get the 239.80 kilonewton per meter for the BMD. Okay, to the main reinforcement. For my beam, I use 6H25, which is equal to 2946 mm per square. Minimum and maximum reinforcement area. For the AS min, I get 230 mm per square, and the AS max, I get 7200 mm per square. For the shear reinforcement, VED that I get before was 132.68 kilonewton. And for the shear link, I use the H8400 and H6100. For the line rearrangement, I get 151.76 kilonewton for the high and the low. And then for the transverse steel in flange, I use H8250 is equal to 201 mm per cube per meter. Okay, as we can see, the deflection of my beam is 0.014 for the P. For the PN was 0.0005 and for P prime was 0. And I calculate all of it, the deflection was okay. Meanwhile, for the cracking, I get to at 4.60 Newton per millimeter square. So the bar spacing that I can make for our beam or for my beam that I calculate is 100 mm, which is decreased or low than allowable spacing, which is 150 mm. So the detailing is we use to H12 and 20 times H8 400 for the link inside the beam. So that's all for the beam A1 to 5. Thank you for listening.
Hi, Assalamualaikum. My name is Intan Nurman and Jufri. So now I will present about my design, which is simply beam A1 5 till 6. So they are given some information to continue this design, and you refer to them such as thickness slab, unit weight, brick wall. The character is GK, finishes QK, fire life exposure. And for the concrete is FCK, FYK, and we assume bar 1 is 20 millimeter. Okay, so for the Ly over Lx, it is calculated that the Ly over Lx is less than 2, hence it is 2 when slab. Okay, for the action on slab, For the self weight, it is 3.75 kilonewton per meter square. Alright. For the distribution of action, it is given that Ly over Lx is equal to 1.8. So we use the action from slab case 7, and we refer the table. Okay, and for the overall depth, which is H, it is equal to 234.46 millimeter, while for the B is 70.34 millimeter. However, the B is less than B minimum, hence we use B minimum instead, which is 120. So 120 we multiple with 240 of H will equal to 28,800. So for the derivative fire and bond required, for the main cover, with regards to fire, it is equal to 24. Okay, next. So now, for the allowance in design for deviation, it is equals to 10 millimeter. For the GK, it is 0.72, and for the QK, it is 1.63. Okay, so for the WD, it is equal to 3.417 kilonewton per meter. For the main reinforcement, for the D is 189 millimeter. For the DS for the B is 51 millimeter. For the design bending moment, K is equal to 0.037. For the K bar, it is 0.167, and it seems that K is higher than K bar. Okay, so for the AS is equal to 108.1 millimeter square. So now for the minimum and maximum reinforcement area, for the reinforcement area minimum is equals to 14.76 millimeter square, and for the maximum is 2,340 millimeter square. For the shear reinforcement, design shear force, it is equal to 161.8 kilonewton, and and for the shear links, it is equal to 0.89. And for tri link, it is equal to we use H6. For the spacing, it is equal to 65.17 millimeter. Okay, so here is the link arrangement. We have the V minimum shear resistance of minimum link is 36 kilo Newton. Okay. Okay, for the additional longitudinal reinforcement, for the additional tensile force, it is equal to 200 kilonewton. For the deflection, the medication for span greater than 7 meter, hence the 7 span need to divide with 8.25, and it will equal to 0.85. For the allowable span effective depth ratio, for the allowable, it is equal to 12.34. For the actual, it is equal to 50.3. For the cracking, the limiting crack width is 0.3 millimeter. For the steel stress, is equal to 130.34 Newton per millimeter square. And that's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Haris Izzuddin bin Nur Azizdin. My metric number is CF200150. Okay, I will present my beam that I calculate. Okay, this is my beam that I calculate, which is in J1A3. Okay, the slip thickness is 1.5 millimeter. 150 millimeter. My unit weight concrete is 25 kilonewton per meter square. My brick wall height is 3 meter, and then my weight of brick wall is 7.8. My GK is 4.69. My QK is 1.93. Okay, the design life is 50 years. Fire resistance, we use R60, and exposure class is XC3. Okay, this is the detailing of our this beam, which is a J1A3. Okay, in the left and right we use H6 spacing 150, and then in the middle we are using H6 175. The conclusion is the project was carried out in group of 5 to propose the structural plans from an architecture drawing for a 2-story building for each floor and the structure detailing for the beams using AutoCAD. Each of member have opportunity to analyze and design one simply supported beam and one continuous beam for first floor beams from the building. At the end of the project, we'll have learned about this suitable and practical beam size and thickness of suspended slab in the structure. We also learn to identify the material properties, the permanent and variable action in a structure. Next, we have learned to analyze and distribute the load for first floor slab to the first floor beam. Besides that, we have come to understand the principle and method of design of reinforcement concrete structure by applying the Eurocode 2 design of concrete structure that adopts the limit state principle that conjunction with other Malaysian standard, including Eurocode Basic of Structure Design that deals with analyze, and Eurocode 1 Action on Structure that cover loading in project. To conclude, there are a lot of decisions that go into every minor detail of designing and building structure. In order to design safe structure that will last for many decades, engineers must stay current on the properties of material, known about the flaws, and research new engineering technology. That's all from us. Thank you.